In this video, I want to give an introduction to Lab 14, talk about the different parts, some of the conceptual ideas associated with it. For the calculations, I'll reference a specific section in the textbook, and you can watch the lecture video for those examples. The video that I'm recording right now is actually going to be this right here, this introductory video in the data sheet for Lab 14. So I'll change this to a hyperlink, and you'll be able to click on the link there to see this video. Also, any notes that I place on the lab itself, I'll save that as a PDF, and that will be available as a link on Moodle as well under the chapter 14, or the Lab 14 heading. Hopefully you have watched the how-to video on how to complete and submit a laboratory in Moodle for this class. And what you'll see in that video is actually I use this image here, and I talk about that the way these labs are designed is that for each part is listed, and you'll have either data in the form of videos, maybe some text, images, or if we're skipping a part, then I'll type that in and say skip, okay? And you use this information then to go in and start filling out this report sheet, okay? So I'll go specifically to the report sheet. For example, you'll play part A video, and then as you're watching the videos, you can record the observations here and then write the conclusion out. In a minute, I'm going to change view and then start talking about the lab itself. I'm just having it side by side just to this is our first lab, be clear on how you're quote-unquote performing the laboratory, okay? Let's go ahead and take a look at the lab report and learn a little bit more about solutions and electrolytes. Lab 14 is associated with Chapter 9, so you really should watch the Chapter 9 videos before completing this lab, and it'll make a lot more sense. And what I'm describing here, I will have assumed that you have watched the Chapter 9 videos, and also it would be great if you have even tried to work some of the problems of mastering chemistry. That'll help reinforce your learning from the videos. Now, having said that, I will talk about each specific and try to give you some idea of how to interpret the information here. So let's just go ahead and take a look at Part A. Part A is dealing specifically with polar versus nonpolar solutes and solvents. And just point out, I'm going to focus on the report sheet, make notes there, but Timberlake does show, a decent description on some of these topics. Like for example, especially Part B, when being specific about the distinction between strong, weak, and non-electrolytes. This image is also in the textbook, and we'll talk about it in Part B as well when I discuss it. Okay. These calculations, this is section 9.4. Whenever Timberlake is going to have you use your laboratory data to do a bunch of calculations, like these types of calculations for Part D, what she will do is in the procedure section at the end of it here, there we go, she'll actually show you the step-by-step process on how to do the calculation, where the 3 and the 1 and the 4 that's in the parentheses there, those are referring to, and I'm just going to bump down to Part D here, the 1, 2, 3, 4, those are the numbers in the parentheses there. So she's referencing data that you have in your report sheet here. Remember, this data is coming from that image that we saw just a few minutes ago. Again, if that's unclear, please watch the how-to video on completing these labs. Let's talk about Part A. Okay, so we want to talk about solubility and how the solubility can give us some idea about the polarity of a solvent or solute. Now in this case it's actually, we're going to figure out the polarity of these solutes here. Water and cyclohexane, let's just write out some notes here. Now this is going to echo what you see in the lecture videos, okay? So water, if you watch those lecture videos, you'll see that I'll talk a lot about water. It is our classic polar molecule, okay? Now since both of these are acting as solvents here, I'm just going to say polar solvent. You know, I'm using language that's, you know, ties in with the experimental part here. And remember, the reason why it's polar is, well, basically you have an electronegative atom. You know, for right now in the class, remember this is a survey course, and so we're just sort of skimming the surface of a lot of topics. And basically, if you see, an oxygen or nitrogen in a molecular formula like H2O, then you're dealing with some kind of polar substance here. Okay, actually, let's do it this way. It's polar, and it could be a polar solvent or solute. Okay. Cyclohexane has a molecular formula C6H12. It's a hydrocarbon. One thing we see in the lecture videos, all hydrocarbons are nonpolar. And again, since cyclohexane is acting as a solvent here, I'll just add that to it. But there are nonpolar solvents and nonpolar solutes. And that's what we're doing here. Depending on how each of these solutes is going to interact with these solvents, then we'll be able to determine whether the solute is polar or nonpolar. And what we have to remember here is there's this phrase, like dissolves like. And what that means is that polar substances will dissolve polar substances. Like, just to write out one of these, let's say a polar solvent will dissolve a polar solute. So, you know, whichever one of these solutes are soluble in water, then it's going to indicate that that solute is polar. If the solute is soluble in the cyclohexane, then, you know, if it's soluble in the cyclohexane, then it's going to indicate that it's a nonpolar solute. And that's all you're doing. And in the video, you'll see that occurring, right? So this is this is where the data here is going to come from the video. And then you'll write in the conclusions there. And just, I don't know, by the way, there's nothing to write there. It's just a blank. For part B, this is going to be the data that you'll collect. Data from videos. And basically what you're doing, and actually I'm going to pan back up to that image so I don't have to redraw all of this. There it is. There's our strong, weak, and non-electrolytes. I talk about this topic in specifically section 9.2 in the lecture videos. This apparatus here, and I think the video demos that you see on that document illustrate it pretty well. Basically, it's just a light bulb, the wires connected to an outlet, and then these electrodes prevent the current from flowing. And if you connect these two with a metal object, it causes the light bulb to glow, and you see that in the videos. The other way to do this in the context of a conductivity meter or conductivity test that we're doing here is that if there's many ions in solution, well, these ions have a tendency to carry electricity through the solution. So for these strong electrolytes that have practically all ions in solution, meaning that the salts have completely dissolved and completely dissociate, again, please see lecture video for section 9.2 for more on that, then it's going to cause the light bulb to glow very brightly. Weak electrolytes dissolve a little bit, they disassociate slightly, and so only a few ions, and if we just go in here and just circle the ions versus all of the molecules in there, molecules do not conduct electricity, only ions. So if we only have a few ions and mostly molecules, then it's a very dim bulb. And then finally here, there's no ions. Without any ions, no light bulb, no light coming in for the light bulb. So bright, dim, none, no light. Then that's the data that you'll see in those videos. That's what you're going to include in. That's what we're going to write down in this table, and then you can draw your conclusions from that information. And then what we do for these labs is that if we complete a section in the lab report sheet, then we will also answer the questions in the report sheet. If there's a section that we skip, like we're skipping part C here, then we will also skip the question associated with part C. We are doing part D, right? That's the data, that's just those images that's in that lab resource. And again, look back at this lab report, I think page 160 is where it was at, shows you how to do the calculations. And again, this is in reference to section 9.4 in the textbook. And just like before, if we do a calculation or if we do an experimental portion of the lab, then whatever questions follow that part, we typically answer those questions as well. And that's it. And actually, I'm going to go back and do that same notation up here. Yes, we do this, we do that, and then we are going to also complete all of those pre-lab questions. Let me go ahead and add a little bit more information here. I want to say, really, it's probably section 9.1 through 9.3 for part A and part B here. That'll cover all the bases. Okay, so once you have these labs, once you have the lab completed, right, you're filling the report sheet out by hand. This should be handwritten information as if you were in the laboratory. Once you have it completed, you can scan it, convert it to a PDF, and upload it to Moodle, which is what I prefer. Or if you don't want to do that, or you're not comfortable doing that, or if you don't have the technology to do that, totally fine. Just take images of each individual page and then upload it into Moodle. And again, please see that how-to video for doing that. By the way, you do not need to scan and upload these pages. I only need where the written work is. Okay, that's it. Thanks.